The understanding of what it takes to design a product from an idea or to solve a problem, and then to assess the outcome of testing of certain prototypes to a finished product can be a daunting task. Windtrans Pump Systems Limited introduces you to the new technology of the Zelda HVLS Pump. We were presented with a problem. Can you develop a pump that can provide high flow at low RPM? Could this pump also be developed to produce a full vacuum, to have almost 100% sealage? Being at low RPM, could this pump also take advantage of high torque, low RPM sources of kinetic energy for operation? During the development, we talked about reduced contact of components, reduction of friction, lower RPM to provide greater longevity. We had to make sure that the pump wouldn't create any hydraulic lock, and we also took in consideration that we would only ask the pump to move components when there was reduced load. First, we took some quick sketches, jotted down some ideas, and then took our ideas and put them into a 3D computer-driven model. We made some assemblies, did some simulation, so then we extracted these parts out so they could be rapid prototyped. We then used SLS rapid prototype methods. The SLS method proved to be invaluable. Parts could actually be assembled, and the pump could actually be used under real-world conditions. Rapid prototyping allowed us to make changes quickly. We could print again within the next couple of days and test. We then turned to some more robust type prototypes, casting, machining. In doing so, we were then able to push the boundaries of the pump design. We pumped water, oil, molasses, and grease, proving that even under these kinds of stresses, the rapid prototype parts could withstand this kind of testing. We were able to reduce the stress on moving parts, and then have them activate, or as I'd like to say, we could ask them to move at times when there was less stress or loading on these parts. Longevity, the speed required to operate, the friction of the moving parts could be reduced, making a product that we felt would be far superior to other pumps on the market. Born from this entire process was the Zelda HVLS Pump, a pump that could move high volumes at very low speeds. The entire process was invaluable. Testing proved that we could run from 1 to 220 RPM and able to deliver 330 US gallons per minute. The most surprising finding was that we could reach over 95% volumetric efficiency and over 78% to 90% mechanical efficiency. The final design was cast, internal parts manufactured, and drive systems designed. We found that the pump could do some amazing things that I feel are unmatched by other pumps. We could generate a continuous pull running between 60 and 120 RPM, producing a full vacuum. The consistent pull of the rotary design enabled us to lift a continuous 4-inch diameter column of water to a full atmosphere within seconds of deployment. We could now use high torque kinetic energy sources that typically run at low RPM and make full use of their energy. The excitement of being involved in the development of a new prime mover, being able to use a mechanical device that can deliver water to school children in a developing country, to lift an oil spill off the surface of the water, or to empty a basement during a flood, makes the effort as a designer and manufacturer most rewarding. Thank you for watching. For more information, see www.windtrans.ca. We look forward to making a difference in your life.